Hey time travellers, it's 1975. Was a time of shabby hair, lapels you could play a football match on, A-line flares, platform boots, tie-dye t-shirts, and some real questionable interior decor. What mushrooms were they on? However, this was right in the middle of the golden age of audio systems. Let's take a look at a really great example. And this is Trio's KA5500. The previous owner told me that the Grim Reaper visited one day and expired this for him. Either we hold a seance or try and bring it back to life. See if we can get its 55 watts back out. Japanese in design, but these came from Trio's plant in West Germany in this decade. For a compact unit, it does have a thumping amount of power. Thus claims a reasonable damping factor of 50 over 55 watts, 100 dB signal to noise. Trio's avoid sustained overload protections in it. Has a nice look to it as well. It's very well taken care of. Well, let's get inside it. Well, all the preamplifier apart from the phono stage is nailed to the rear of the fascia. Power amplifier is clear to see. I need to inspect all the usual areas that can have horror moments. It's cleaner than my mum's driving licence. Normally they're filthier than a very special corner of my mind. I'm straight down to the compressor to evict the spiders, ants, dead flies, 40 years of minging dust, crud, etc. I'm looking at the moment for burns, cracks, modifications by previous gopping morons, other work by proper engineers, and there doesn't seem to be any obvious signs of explosions or burns. Going back to the thought of whether you restore or repair, I think quite a lot of the capacitors and other components in here are just going to get removed and renewed. They've been in here way too long, and there's some sensitive areas that really could do with some fresh items in. I suspect things have gone wrong with the power amp or the power supply or both. There doesn't seem to be any obvious damage. Let's take it apart. Well, now that the base is off, I can then look at the underside here. I noticed that they've got a lot of those turned pin arrangements where they've coiled the wire around these pins, and they go fragile through corrosion and can come away through fatigue. Although on inspection I'm not seeing any of that. It depends which one comes off as to does it influence any other damage in the system. But on this occasion there's nothing there. They all seem to be connected. Now, it's always good to look at the lid because it can tell you a story. That looks like the heat bloom from the bridge rectifier card rather than actual burn or blow up of component, but I could be wrong. Oh look what I found. Well, something needs to happen there, and something has caused that. I need to go through all the components. I'm going to repair first, but I'm going to count the components, look at the types of transistors we've got, types of capacitors. Do I have them in stock? Oh, that's going to end up covered in dust, and that trimmer down there is going to end up filthy. And repair first and then do the restoration. So I'm going to measure the output devices, because I've got a suspicion that they're the cause of that fuse going. On a passive test, I couldn't find anything wrong with that bridge rectifier and the other elements of the power supply, so I've moved into the power amplifier, specifically these power output devices, and yes, one of them's got a completely blown base emitter junction, and another one is short circuit across all 3 pins, base collector emitter. So yes, that would have easily wiped that fuse out. Now I've done quite a few measurements across the transistors. There's various anomalies. There's a couple of short circuits on there as well. That relay is suspect. This transistor has caused its own driver transistors and all the other things in the DC chain to be wiped. So those need replacing. And I need to go to the circuit diagram now and have that in front of me whilst I then go through the procedure of changing those components. Make sure I'm getting things the right way around, I'm putting the right things in, and I check the specifications on all the devices I put in. And here is the circuit diagram. The fairly standard differential input amplifier straight to class A. The signal hitting a base of QE1 with the neg feedback transistor is QE3 tied to the negative rail. A class at sensor stage is QE5 right there. QE7 are offering constant current source for QE9. Bias transistor sending the high voltage gain swing to those two guys at the end, which is QE19 and QE21. Those two then drive the power output transistors, which are in those square boxes at the end to denote that they're on the heatsink, and those are the items that we're going to need to replace. So QE23, QE19, QE21, most of those transistors are going to come out and get renewed. It's time to look at that fuse again.
Hold on, man, what is this?
I've got to say something about fuses because you tend to see a lot of different things going on, and this is one of them. Well, yeah, quite. I do see this happening a lot, and it's not the right thing to do, or perhaps.
Maybe we could build a fire, sing a couple of songs, huh? Why don't we try that?
Or you could do it correctly, and well, this is what I call correct. It's a time lag, 2.5 amp, exactly what should be in that position. I've already done the repairs at this stage. It's got new power transistors in it, the new drivers, everything we spoke about before. Now I'm about to put power into it for the first time. I've got a Variac. It's a very precious piece of equipment. I recommend to anybody doing this sort of work to have one of those. It means you don't have to apply power to it straight away, not full power anyway. And if there is anything else that's harmful in there, you're going to notice it straight away without causing any more damage or wiping out your correcting work. There's only about 90 volts in going into it in this stage, just to see if anything is getting stressed. A vital piece of test equipment, one Variac set at 90 volts and a kilowatt meter. That allows me to see if the transformer, prior to having any of the other circuitry involved, to see that the primary and secondary of a transformer is healthy. If not, then I'm going to know that straight away without doing blowing any other fuses or anything like that. So I do recommend having this pair for any aged equipment when you've got large currents involved in failure mode. If you guys do anything different or use anything different, just mention it in the comments. We all have a different expertise, etc. Now I'm starting to look at the way the circuit's behaving, dialing it all in with the bias, with the new devices in, and also the other items that I want to replace to fully restore this. There's a heap of capacitors in there that are in sensitive areas of this amplifier, and a couple of the resistors that are marked in yellow. Some of these are to do with the gain bandwidth product of the amplifier. You've got the Zobel stage off the 56k negative feedback resistor. And then there's another one on the Class A, the 330 mic. With those being out of range or out of their tolerance, you can end up with differences in bandwidth between left and right channel, which isn't a good thing to do. So to dial those back in, I need to get those replaced. There's also a dropper resistor of 5.6k onto the differential pair, which is nailed down by a 14 volt Zener and its capacitor, so they're going to get sorted out as well. Actually guys, have a look at the 220 picofarad capacitor on the input of this stage, right on QE1. Now this is in series with 100 ohm. Now I understand 1 over 2 pi RC, but I've never seen a what is an interference clamping capacitor get 100 ohms impedance stuffed in front of it. If you have a look at this is the SA 9800 by Pioneer, and its input, very very similar device design, current mirror amplifier on this one, but as you see, the capacitor's straight to deck. So I'm curious about this. If anybody's got any knowledge about this, this is the NAD 3030. The 200 picofarad capacitor is nailed straight to deck again on this one. I don't know why you'd put 100 ohms impedance in the way of it. I've never seen that before. All the PA amplifiers I've ever worked on, unless somebody at Trio has been misinformed or some apprentice engineer has been having a fiddle, I don't know. But if somebody, a designer out there, similar experience, has got some answers, I'd really love to hear about it. I just find it a little bit unusual. The next diagram I'm going to pull up is for the Sceance AU317, a very popular amplifier. There it is, and that's an FET input stage. The 220 picofarad is shutting down the FET input stage at very high frequencies, and there's your interference capacitor on the front end. So I'm curious. That's an unusual behavior. I've not seen it before. Do I change it? Do I keep it? No, I think I'll keep it original because it's not harming anything, but it's not what I'm used to. I'll not bore you with me desoldering everything and soldering away. That just takes too long. Besides, I need to concentrate. I can't make a video and do this at the same time. Here's an interesting point. This is a 45-year-old capacitor, 220 microfarads. And just to show you how there's a lot of witchcraft and druidism about recapping amps out there. That's 220 microfarads, well within specifications, low ESR, 0.3% loss, and that is 40 odd years old. So don't believe all the witchcraft you hear about out there on the interweb. And this is a miniaturization. 220 mic, 63 volt against 100 mic, 25 volt, and there's 1,000 at 25 volt against 100 at 25 volt. So we've come a long way on the material science of capacitors. There are certain capacitors you shouldn't change. NPs, for example, non-polarized, and I've seen so many mistakes made that people haven't been looking for the non-polarized, as they've just gone whacked in a whole bunch of silly capacitors in all sorts of silly places with all sorts of silly chemistries, and they wonder why, oh, where's all the bass gone? It's working now, but the little wee meter wiggly jigglies that everybody likes is actually going negative and positive. I've seen this before. It's when the ground rail is missing from the circuit for the meters. So it could be one of those wound wires on something, but I've had to take the facier off to go and find out. It's clad in steel at the back, so I've got to remove the meters. And yes, the connecting link is there for the grounds to the meters, but the actual ground wire has broken off. It's actually sat inside the pocket at the back, and there it is. And it's not actually connected to the meters, so the factory has made that too short to actually meet the meters, so I've had to adjust that a bit to make it work. And now all your metery wiggly jigglies are happening. Now I won't be able to play any copyright material on here, but just imagine. I'm going to give it a thorough thrashing anyway. And thank you very much, and I'll see you next time.